Well, dear viewers, today we will discuss few points related to the diesel cycle. In the previous videos, we have seen the process used in the Otto cycle. So the Otto cycle that is helpful for the petrol engines. Similarly, the diesel cycle. The diesel cycle that is useful in the diesel engines. That is called the compression ignition engines. So the petrol engines are called the SI engines. So the SI engines works on the Otto cycle. The compression ignition engines, CI engines, they works on the diesel cycle. So in this video, we will discuss the sequence of operations in the diesel cycle and how can we practice the PV and TS diagrams. So the sequence of operations are similar or same. Either it is a petrol engine or the diesel engine, the sequence of operations are same. So in the petrol engine, the air plus fuel, the charge is injected into the cylinder. But whereas here in the diesel cycle, only air is admitted into the cylinder. So the air is admitted into the cylinder at atmospheric pressure, and again air is get compressed. Whenever piston moves from BDC to TDC, the air is get compressed. So the first operation occurred is the compression. So the air is get compressed. Similar to the petrol engine Otto cycle, here also the compression occurs at isentropic. So the first operation occurred in the engine cylinder is the compression, isentropic compression. So the air is get compressed. Then the fuel, that is diesel, is admitted into the cylinder. So the diesel mixes with the hot air. At what points the combustion occurs. Therefore, it is called the compression ignition engine. It is a compression ignition engine. So the heat addition occurs. The charge that is diesel and the hot air both mixes, and again whenever it exceeds the ignition temperature, then at multi points the combustion occurs, the heat addition occurs. So the next operation is the heat addition. So in the Otto cycle, there is a constant volume heat addition. In the diesel cycle, it is maintained the constant pressure. That is a constant pressure heat addition. So the next operation is 2 to 3, that is the constant pressure heat addition. All the operations, the sequence of operations, they are same. So the next one is the gases are produced at the higher pressure and temperature, they exert piston forces onto the piston. Then the power is produced. It is called expansion. So the next stroke, the next operation is the expansion. So the expansion is, compression is at isentropic, the expansion is also occur isentropic. So that is 3 to 4. That is 3 to 4. Let. So the gases, they exert pressure over the piston, then the expansion occurs. Later the gases they leave. So before leaving, they use its heat. That is called the heat rejection. So the heat rejection is the next operation that occurred inside the cylinder. So the heat addition is at constant pressure, and the heat rejection, similar to the Otto cycle, the heat rejection is occurred at the constant volume. So the 4 to 1 is the constant volume heat rejection. So if you compare the operations occurred in the petrol engine and diesel engine, all operations are similar except the heat addition. In the Otto cycle, it is maintained the constant volume. In the diesel cycle, it is maintained constant pressure. This is another important question asked in the competitive examinations. So how can we remember the cycle? So the first operation is the isentropic. Entropy is constant. The second operation is the heat addition, constant pressure heat addition. Pressure is constant. The third one is the expansion, and again entropy is constant. The fourth one is the heat rejection, the volume is maintained constant, therefore it is called V. So the cycle you can remember for the diesel cycle as SPSV. This is the easiest way to remember the operations occurred in the cycle. SVSV, that is for the code for the Otto cycle. SPSV, that is the code for diesel cycle. If you remember the sequence of operations, that is become very simple to draw the PV and TS diagrams. So we will practice drawing the PV and TS diagrams. First we will practice the PV diagram. The pressure is taken on the y-axis, the volume is taken on the x-axis. So constant pressure means horizontal. Constant volume means vertical. Other than this curved line, this is one the blind suggestion that is given to draw the PV and PV diagrams. Constant pressure is horizontal, constant volume is vertical. Other than this, the lines are the curved lines. So you see the first operation, that is isentropy compression. Isentropy. Constant pressure is horizontal, constant volume is vertical. Other than this curved line. So 1 to 2 is other than this. Therefore, it is become the curved line. So similar to the previous cycles, before compression, the high volume is before compression, high volume and low pressure. So the air is admitted, air is get compressed. So the compression is isentropic. Due to the compression, volume decreases, pressure increases. Therefore, that is a curved line, the isentropic compression. Isentropic compression. So 1 to 2 is isentropic compression. Then the heat addition. The heat addition. The hot air mixes with the diesel, then the combustion occurs. So during the combustion, the pressure is maintained constant. Therefore, the constant pressure heat addition. Constant pressure. Constant pressure means horizontal. Either horizontal forward or horizontal backward. Due to the heat addition, so you take the gas, you add heat, what happens? The volume increases. Similar to here. So 2 to 3 is the heat addition. You add heat, then what happens to the volume? Volume increases. Therefore, you have to draw horizontal forward. So 2 to 3 is the heat addition. The heat addition is the constant pressure heat addition. So we reach up to point 3. Then the expansion, similar to the previous cycles. The expansion is isentropic. Constant pressure is horizontal, constant volume is vertical. Other than this, the curved line. So that is become curved line. Either curved downwards or curved upwards. Expansion. Because of the compression, pressure increases. Due to the expansion, pressure decreases. Therefore, you have to draw the curve downwards. So 3 to 4 is the expansion, isentropic expansion. Then the heat rejection. The heat rejection is maintained the constant volume during the heat, similar to the Otto cycle. Here also, the volume is maintained constant during the heat rejection. So volume is constant. That means vertical. Vertical upwards or vertical downwards. This is the heat rejection. Due to the heat addition, pressure increases along with the volume. Due to the heat rejection, the pressure decreases. Therefore, you have to draw vertical downwards. So it is the heat rejection, the constant volume, heat rejection. It is the diesel cycles, PV diagram. This is simple. So compression, expansion, isentropic. Heat addition, constant pressure. Heat rejection is constant volume. Only the difference between the Otto cycle and diesel cycle is the method of heat addition. In the Otto cycle, constant volume heat addition. In the diesel cycle, constant pressure heat addition. That's all. The remaining are all same. The operations are same. So how to draw the TS diagram? So the temperature is taken on the y-axis, entropy is taken on the x-axis. So constant temperature, horizontal. Constant entropy, vertical. Other than this are the curved lines. Other than this, they are the curved lines. So how to practice drawing the TS diagram? Simple. So 1 to 2 is the compression. The first operation is the compression. 1 to 2 is the compression. Isentropic. So that is isentropic compression. You forget about the PV diagram. We will focus on to the TS diagram. So entropy is constant. Vertical. Vertical upwards or vertical downwards. This is a compression. Due to the compression, pressure increases. Also the temperature increases. So 1 to 2 is the vertical upwards. So 1 to 2 is the compression. The type of the compression is isentropic compression. Isentropic compression. Then the heat addition. So the constant temperature is horizontal. Constant entropy is vertical. Other than this, the curved line. So this is a constant pressure line. Constant pressure line is other than these operations. That is become curved line. Either curved upwards or curved downwards. This is the heat addition. Due to the heat addition, the temperature increases. Therefore, you have to draw vertical, you have to draw curved line upwards. So 2 to 3 is the heat addition. The heat addition is the constant pressure heat addition. You reach point 3. 3 to 4 is expansion. You can see the previous case similar to that, the expansion. Constant temperature is horizontal, constant entropy is vertical. So this is isentropic. The isentropic is the vertical line. Whether the vertical upwards or vertical downwards, this is expansion. Due to the expansion, pressure decreases. Also the temperature decreases. So you have to draw the vertical downwards. So this is the expansion, isentropic expansion. You reach point 4. Then 4 to 1 is the heat rejection. The 4 to 1 is the heat rejection. So what is the type of the heat rejection? Constant volume. So constant temperature is horizontal, constant entropy is vertical on the chart. So this is a constant volume other than this. So that is become the curved line. Whether it is a curved upwards or curved downwards, this is a heat rejection. This is a heat rejection. That is become the curved downwards. The temperature decreases. Therefore, that is become the curved downwards. So this process is the heat rejection, the constant volume heat rejection. So compression, expansion, isentropic, constant pressure, the heat addition, constant pressure, heat rejection is constant volume. This is the PV diagram and this is the TS diagram. This is the TS diagram. So normally the efficiency of the cycle, diesel cycle. So anyone, so that is the heat addition minus heat rejection divided by the heat addition. So the mathematical expression for the heat addition, heat rejection, you can take and you can substitute and you will get the efficiency of the diesel cycle. So the diesel cycle's efficiency will be around 30% to 35%. So around 35% the efficiencies are maintained in the diesel engines. And how can we write the diesel cycle and its efficiency? So we will take another video. At that time we can practice. So here my focus is on to the sequence of operations in the diesel cycle and how to practice the PV and TS diagrams. So these are shown here. Thank you.